Hello everyone and welcome back to Introduction to Number Theory. This time we will talk about rational approximations. Well, of course, rational approximations for irrational numbers. We all understand that rational numbers form a dense set on the real line, which means that any irrational number can be, for any irrational number, we can find arbitrarily close rational numbers to this irrational number. But the problem is, as closer we get to the irrational number, the greater the denominator becomes. So the denominator of rational numbers that are close to this irrational number, they tend to infinity. And our goal now is to find a way to form approximations of irrational numbers, rather good approximations, with rather small denominators of these rational numbers. And continued fractions will be very useful now. So the theoretical basis is the following. If we decompose an irrational number alpha into a continued fraction, we will gain an infinite continued fraction. And if we consider its convergence, convergent of number n and convergent with number n plus 1, we understand that alpha itself will be somewhere between these two convergences. And at the same time, the distance between these convergences will be equal to 1 over the product of their denominators. And obviously it is less than 1 over qn squared, because qn is less than qn plus 1. All this we know from previous lessons. Well, alpha is between these two fractions, and the distance between these two fractions is less than 1 over qn squared, and qn is the denominator of one of them. So from this it follows that the distance between alpha and nth convergent is less than 1 over square of the denominator of this convergent. Well, this is a rather good approximation. Let's check for an example, just to show you how good this approximation can be. For instance, consider the most famous mathematical constant pi, equal to 3,1, 4, 1, 5, 9, and so on. We know that there are infinitely many digits after the comma. And one of the simplest approximations can be obtained by just taking 3.14, which is a rational number, of course, and it can be simplified to a fraction 157 over 50. Well, denote this approximation by x and find the distance between pi and x. It is equal to 0,00159 and so on, which is approximately 1 over 600, just approximately. However, if we take the continued fraction for number pi, and we have already found this continued fraction, its elements, and just take a convergent not so far from the beginning of this continued fraction. Namely, if we take y equal to 3 plus 1 over 7, which is actually 22 over 7, which is the approximation for pi used by Archimedes himself, then the distance between pi and this new approximation y is equal to 0.00126, which is approximately 1 over 800. So notice that simple decimal approximation gives denominator equal to 50 and accuracy approximately 1/600, while the approximation using continued fractions gives us denominator equal to 7 and accuracy approximately 1/800. Better accuracy and much less denominator. Well, this is how continued fractions can be useful if we need to have rational approximations of irrational numbers.